Hey there. So today we're going to talk about how to find area when you might not have all the information that you need right away in order to find the area. So this is going to be using right triangle trig and the Pythagorean theorem. So let's start with a right triangle. Um, let's say I want to find the area of this triangle, and we know this angle is 49 degrees, that that's a right angle, and that this side is 10 inches. So in order to find the area of a triangle, we need to know the base and the height, because area of a triangle is base times height divided by 2. We talked about all of that earlier this week. So we have the base. We need to find the height, though, because the base and the height must be perpendicular. I only know this side. I also need to know this side, so I need to solve for the height. So this is where we're going to use some right triangle trig here. So first thing I'm going to do is, if I'm looking for a missing side, with the respect to the angle that I know, I'm going to label my sides opposite adjacent hypotenuse. So H is the opposite side of my 49-degree angle. 10 is the adjacent side, because this side that we also don't know is the hypotenuse across from the right angle. But we don't care about that one. We only care about these two. So now that I know I'm dealing with opposite and adjacent, that means that we're going to be working with tangent here. So I'm going to set up my equation. Tangent of 49 degrees equals h over 10. Now, make sure your calculator is in degree mode before you do anything else. But to solve this, all we have to do is multiply by 10 on both sides. The 10s cancel, and into your calculator you type 10 tangent 49, and that will give you your height. So if we do that, we get 11.504 equals height. So that would be this missing side here. And now we do have enough information to find our area. So we're just going to plug in 10 times 11.504 divided by 2. And that would give us 57.52 square inches. That would be our final answer here. So this is just like the area problems that we've been doing earlier this week. It's just combining it with some right triangle trig that we've also done in weeks past. Okay, so and using Pythagorean theorem and right triangle trig, you're not limited to just right triangle problems, because there's triangles everywhere. So let's do another one that involves a parallelogram this time. And we use the Pythagorean theorem just for funsies. So for this one, we've got our parallelogram. We know that this side is 10 centimeters. We know that just this distance here is 6 centimeters. And then the other part of that distance is 9 centimeters. Okay, so this is going to require us to remember area of a parallelogram is base times height. And our base here is this whole side, so 9 plus 16, which is 15 centimeters. But 10 centimeters is not the height. We learned that also earlier this week, that the base and the height have to be perpendicular to each other. So this would be our height instead. So we need to solve for that missing side, and luckily enough, there's this little right triangle going on here that we can use the Pythagorean theorem, a squared plus b squared equals c squared. Remember, the one that's important that you have in the right spot is c, the hypotenuse, and it's across from the right angle. So this side right here, the 10 centimeters, that is going to be c. So all we have to do now is go 6 squared, since that's kind of our a, plus h squared, since that's the b, equals, not c squared, 10 squared, because 10 is c. All right. So then we simplify this. 36 plus h squared equals 100. And you might have already recognized this is a Pythagorean triple. If you did, you already know that the height is 8. But we can go ahead and solve this through. We'd subtract 36 from both sides. We'd get h squared equals 64. Square root both sides, and we get h is 8. Okay, so if the height is 8, we know the base is 15. Now we just have to multiply the two things. So it's going to be 15 times 8, which is 120 square centimeters. So that would be our final answer for the area. Okay, so again, these aren't the only situations too where you can use right triangle trig or Pythagorean theorem to help you find area. There's a lot of other situations and shapes that this will work for. I'll show a couple of common situations that you'll see before we get started on our assignment here. Another one that you might see using Pythagorean theorem when it's not directly a right triangle, you could end up with a picture like this where you have a triangle and maybe you know that this base is 7 centimeters and you know this side is 10 centimeters, but your height, it's one of those situations where you had to extend the base a little bit and maybe you know that this is 8 centimeters and this is your height. So you would have to use Pythagorean theorem on this triangle here to solve for the height before you can use 7 as your base. The only thing that people tend to mess up with on this one is that they think the whole thing is the base, when really all I want is the area of this triangle right here. So the only part of my base that I need is 7. That would be the base. And then whatever you get for the height using Pythagorean theorem would be the height that you use. So there's another situation that you might see. And then one more that you might end up with as well is if you had a parallelogram and let's say we know this angle is 63 degrees and this side is 10 centimeters and this is 15 centimeters and you want to find the height here. So you would have to use this right triangle here and you'd have to use sine to solve for your height, and then your base would be 15 centimeters because sides that are across from each other are congruent. So this side down here would also be 15 centimeters, so that would be your base. Okay, so those are some of the common scenarios that you'll see using right triangle trig, Pythagorean theorem, helping you find information that you need in order to solve for the area. Hopefully this was helpful. If you have any questions, feel free to send me an email, comment, or come to office hours. Have a great day.